Hey everyone, so in this video, we are going to discuss the concepts of factors and multiples. I'm going to discuss at a high level, how do you understand what are factors, what are multiples, how do you write them down, and how do you figure out how to find out the LCM and how do you find the GCD. Okay, these concepts are really important, so make sure that you go through it really well. If you understand these concepts, then when you come for the session on Wednesday for Wednesday with Quizzes, you'll be able to understand, you'll be able to apply these concepts in those questions. And by the way, if you like the video, make sure to click on the like button and also subscribe to the channel, guys. Let us try to understand what are factors and multiples. Factors, also known as divisors, are those numbers that completely divide the original number. So if we say that A is a factor of B, then what we mean is that the number A will completely divide B since it is a factor of B. Okay, so focus on the definition. Factors completely divide the original number. So in this case, if A is a factor of B, then A will completely divide B. And in that case, what we can do is, if the question is based in terms of variables, then you can set up an equation and write B by A is equal to K, where K is an integer. And it's very obvious, right? If A divides B completely, then when we write B by A, we'll get an integer. Here are a few examples. So for example, if you take the number 6, 6 can be written as 1 times 6, and 6 can also be written as 2 times 3, and it can also be written as, once again, 6 times 1. But that doesn't give us any new factor. So we'll stop at 1 times 6 and 2 times 3, and we can infer that the factors of 6 are 1, 2, 3, and 6. Now notice what we did here was we tried to take the original number and break it down into two, as a product of two numbers. This way we can find out all the factors of the original number. Okay, and we'll keep on writing it as a product of two numbers till the point we get some unique values. So these four numbers, that is 1, 2, 3, and 6, notice that they will completely divide 6. So if you divide 6 by 1, you'll get 6, 6 by 2, you'll get 3, 6 by 3, you'll get 2, and 6 by 6, you'll get 1. All these cases, all these four numbers will completely divide 6. So they are known as factors. I hope it's perfectly clear. Now let's move to multiples. Now multiples are numbers which can be obtained by multiplying the original number n with a non-negative integer. Okay, so if I want to find out the multiples of n, all I need to write is multiples of n would be k times n, where k is a non-negative integer. Okay, so for example, if I want to find out the multiples of 4, all I have to do is write down multiples of 4 would be k times 4. And k, since a non-negative integer, we can start putting values of k to get various multiples of 4. So 1 times 4 would give us 4, 2 times 4 would give us 8, 3 times 4 would give us 12, and so on and so forth. So the multiples of 4 are 4, 8, and 12, and so on. Now, I've seen people for getting confused between factors and multiples. So, what we have done is we have created a way to easily remember it with the help of a number line. Now, let's take the number 8. Now, if the number 8, for the number 8, the factors of 8 are 1, 2, 4, and 8. And if you want to find out the multiples of 8, we can write it as k times 8, where k is a positive integer, and we can substitute the value of k as 1, 2, 3, and so on. And on doing so, we'll get the multiples of 8 as 1 times 8 is equal to 8, 2 times 8 is equal to 16, then 24, and so on. Now, as you can see on the number line, factors are basically numbers that are less than or equal to the number. So in this case, the factors are less than or equal to 8. Okay, and if they are less, they will definitely divide the original number 8. So that's the best way to remember it. Factors are numbers which are less than or equal to 8, because factors are numbers which completely divide the original number. Okay, now, while multiples of 8 are numbers that are equal to or greater than 8, and these are the numbers which will definitely be divisible by the original number 8. Okay, so whenever you get confused, just keep in mind that factors are obviously numbers which are less than or equal to the original number. Multiples are either greater than or equal to the original number. When you're learning about factors and multiples, it is also very important to understand the concept of least common multiple and greatest common divisor. So I'll give you a brief idea about these two things, because the session that we're going to take on Wednesday, we're going to apply these concepts there. So a basic understanding of LCM and GCD would be great. Now, to understand LCM, let's take the numbers and the multiples. Okay. So for example, if you want to write down the multiples of 12, we can write these as 12, 24, 36, 48, 60, and so on, right? How do we write multiples of 12? It will be k times 12, and then you keep on changing the values of k, 1, 2, 3, 4, and you get these values. Now let's say we want to find out the multiples of 30. So what are the multiples of 30? It's 30, 60, 90, 120, 150, and so on. And let's just say the question asks you to find out the least common multiple of 12 and 30, or the common multiples of 12 and 30. How are you going to do that? So if I want to find out the common multiples of 12 and 30, as you can notice, they are 60 and 120, and there are other multiples too. And in this case, 60 is the smallest or the least common multiple of 12 and 30. Okay, so this is the least. But if you notice, this is not an efficient way to find out the least common multiple. You cannot keep on writing down numbers. And in this case, we could easily find the 60 because the numbers 12 and 30, they were small numbers and it was easy to work with them. But let's just say if we have to find out the LCM of 2 to 3 numbers together, this is not a very efficient process. So what we are going to do is we are going to learn a method which is known as the prime factorization method. So the steps are pretty simple, and we have broken it down into simple steps so that it is very easy to remember. So the first thing that you need to do is prime factorize each number. So if I want to find out the LCM of 12 and 30, I'll prime factorize 12 and 30. So I can write 12 as 2 squared times 3 to the power 1, and 30 as 2 to the power 1, 3 to the power 1, and 5 to the power 1. Okay, the second step would be to take each prime number and their highest power. So when you're taking each prime number, they're like, for example, all the prime numbers unique that are present in 12 and 30. So in this case, the prime numbers that are present in both of them are 2, 3, and 5. So we'll take all three of them. And then what we are going to do is that we need to take the power, the highest power. So in this case, the highest power of 2 is 2, the highest power of 3 is 1, and the highest power of 5 is 1. So the LCM would be 2 squared times 3 to the power 1 times 5 to the power 1, which is going to be 60. So the way I remember it, or the way it's easy for me to remember, is when I'm looking for least common multiple, I need to do just the opposite, take the highest power. Okay, that way you'll never make a mistake or never get confused what power you need to take. Now, why are we doing this is also very important to understand. See, what are multiples? Number one, multiples, if you remember, are numbers which are greater than or equal to the given numbers. So when I'm trying to find out a number which is greater than or equal to 12 and 30, the number logically has to be greater than or equal to both of them, right? That's point number one. Number two is, what are multiples? So the multiples are basically completely divisible by the original number. So these numbers 12, 24, 36, 48, 60, they're all divisible by 12, and 30, 60, 90, 120, they're all divisible by 30. So I'm looking for a common multiple. That multiple should be divisible by both 12 and 30. Okay. So for example, if I take 2 to the power 1 instead of 2 to the power 2, okay. So if I take in the LCM 2 to the power 1, then that LCM would be divisible by 30, but it won't be divisible by 12, right? Because 12 has 2 square. So if I take 2 to the power 1, I will not be able to divide the LCM with 12, the multiple with 12. So that is why, to ensure that we have a number which is divisible by both the given numbers, we take the highest power. That's the logic behind it. Okay. If you've understood LCM, GCD also works on similar lines only. Let's say, for example, what are divisors, by the way? Divisors are numbers which completely divide the original number. So for example, if I want to find out the divisor of, say, 18 and 42. Now, what are the, so if I want to find out divisors, by the way, as I told you, divisors, factors, they both mean the same thing. So first of all, let's write down the factors of 18. The factors of 18 would be 1, 2, 3, 6, 9 and 18, and the divisors of 42 are going to be 1, 2, 3, 6, 7, 14, 21, 42. Now you don't need to worry about how we found this because we are not going to use it as such. I just want to show that what are the common divisors of 18 and 42. In this case, we can notice they are 1, 2, 3, and 6. Okay, and 6 is the greatest common divisor, which is a divisor which is common to both of them, and the number which completely divides 18 and 42. But as you can see, it's an inefficient process. So we are going to go back and resort to the prime factorization method. The method again is pretty simple. We prime factorize. The first step still remains the same. You prime factorize each number. So if when I prime factorize 18, I get 2 to the power 1 times 3 square. And when I prime factorize 42, I get 2 to the power 1, 3 to the power 1, 7 to the power 1. And step 2, we need to work with the prime numbers and the powers, right? Now, this is the greatest common divisor. The first thing that you can remember is that we need to take the lowest power. That's point number 1. The only difference between the other difference between LCM and GCD is that, see, in GCD we are looking for a number which completely divides 18 and 42. So in this case, I'm not going to take all the prime numbers which are present in both of them. I'm just going to take the prime numbers which are common in both of them. So the prime numbers which are common in both of them are 2 and 3. So I'll take 2 and 3. And I'll take the smallest power, which is 2 to the power 1 and 3 to the power 1. And the GCD would come out to be 6. Now, why did we not take 7 in the GCD? Because remember, what are factors? Factors or divisors are numbers which completely divide all the numbers. If I take 7 in my GCD, will 18 be divisible by 42? No, right? 18 is not divisible by 7 if I take 7 in my GCD. Similarly, why did I not take a higher power? If I would have taken 3 square in my GCD, now having a 3 square is okay when I'm dividing the GCD with 18. When I'm dividing 18 by the GCD, completely works. But in case of 42, if I take 3 square in my GCD, 42 won't be divisible by that divisor. So that is why in this case, in case of GCD, two things that you need to keep in mind is when you're looking for greatest common divisor, we take the smallest power. And since divisors are factors which divide the original number, I need to divide the numbers that like 18 and 42, both of them. I just need to take the common prime numbers. Okay. So we are going to discuss some of the higher applications of LCM GCD in Wednesday with quizzes in our session on Wednesday. So I would like you to, I would highly encourage you to attend that. And if you enjoyed this session, if you like this video, I would recommend subscribing and liking this video, guys.